now on to lesson 8. We're going to start talking about how to name specific functional groups. The first two I'm going to start out with are haloalkanes and ethers. The reason I'm starting with these two is because the alkane main chain actually takes priority in the naming, which means that the functional group is just named like a branch, right? So since we already know how to name branches, it'd be easy to start with these two. So with haloalkanes, all we're doing is adding halogens to our alkane. So say for example I start with a nice easy alkane, like 1, 2, 3, 4, 5. That's going to be a pentane main chain. And the halogens that we generally see could be fluorine, chlorine, bromine, or iodine, right? And we just name them, say we put a chlorine there, as a branch on the pentane. So since this chlorine could go on numerous different carbons in the chain, this is going to be a chlorine on the 2 carbon. And all we have to do is write 2 for the location, chloro, so all of our halocarbons are going to end with O, so chloro, and then the name of the main chain, like we've done before, pentane. And so we can combine this now with other things that we've already learned, such as if we have a methyl branch on 1 carbon and say an iodine on another carbon, right? Then this would be 1, 2, 3. So we could call this 3 iodo. Two methyl. 1, 2, 3, 4, 5 pentane. And the reason we're calling it 2-methyl and not 4-methyl, right, is because if we count from this side, 2, right, was lower than if we counted from this side, call it 1, 2, 3, 4, right? So 2 is lower than 4. The iodo is going to be at 3 regardless, and the same alphabetic principle applies as well. I in iodo comes before M in methyl, so we list the iodo first, and then the methyl, right? So that's relatively easy. Now, if you remember from the intro lesson, ethers, right, are things that are connected by carbon chains, which are connected by oxygens. So if we put R could be any extended carbon chain. So any extended carbon chains, right, which are, we can even make them different carbon chains by calling them R1 and R2, right, which are connected by an oxygen, would be an ether functional group. Now, what we're going to do is we're going to find the main chain by finding the longest carbon chain. So if R1 is longer, it's going to be the main chain. If R2 is longer, it'll be the main chain, right? So if I just make a random carbon chain, right, and then I connect an oxygen with a carbon chain on the other side, right? I've color-coded it, so here in black is the longer carbon chain, so that's going to be our main chain, right? So this would be 1, 2, 3, 4, 5, right? So that's going to be pentane again. And the way we name this ether side chain is that since it's only got 1 carbon, it's going to be meth. And since it has an oxygen that it's attached to, it's going to be methoxy, right? So this is just a methoxy group, right? And of course, we don't want to name this position because that's actually just the bond where the oxygen is at. We're not going to number this position, right? Because that's not actually a carbon. That's the last carbon that's connected to the oxygen there. So this is carbon number 1, 2, 3, 4, 5. Right, obviously, if we not numbered it the other way, 1, 2, 3, 4, 5, right, we'd have the methoxy group on a 5 carbon, whereas here we have it on a 1 carbon. So again, the rule of lowest numbers. So all we're going to do is say that this is a 1 methoxy pentane. Right. And I say this is a 1-methoxy-pentane because obviously we could put this methoxy group or any other ether group on a different carbon. So for example, say I start with the same pentane, 1, 2, 3, 4, 5. And this time I'll draw on a different carbon. So here's going to be my ether group, and let's give it 2 carbons this time, right? So still my longest chain is the 5-carbon chain, and this is only a 1-2 carbon chain. So now, because it's a 2-carbon chain on the other side of the oxygen, it's an ethoxy group. And the ethoxy group is attached to the 2nd carbon on pentane. So this time we're just going to call it 2-ethoxy, because it's attached by an oxygen. And it's on a pentane main chain. Right? And of course we could add other branches as well, right? If I wanted to put a methyl group here, right, then I could call it a ethoxy methyl pentane, right? It's the same naming system as before, where you just give the numbers and you list the branches in front of the main chain. So I think that's pretty much it. It's relatively simple with these 2 functional groups, right? We just add the name of this new branch, right? Either a halo branch or an alkoxy branch, right? Where we have an alkane attached to an oxygen, so it'll be an alkoxy. So you can have methoxy, ethoxy, propoxy, butoxy, pentoxy, etc. Right? Okay, so next we'll be on to naming new functional groups which actually change the name of the main chain.